Gamma Andromedae, or Almach, is the third brightest point of light in the northern constellation of Andromeda. It is a multiple star system approximately 350 light-years from Earth. The system is drifting closer to the Sun and has a radial velocity in the range of -12 to -14 km a second. It can be found in the same area of the sky as the Triangulum Galaxy, the third largest in our local cluster. Hi everyone, Vega here, and in today's video we focus our gaze towards these two wonderful objects that appear so close together in the sky. So let's get to it. In 1778, German physicist Johann Tobias Mayer discovered that Gamma Andromedae, or Almach, is actually a double star. When examined in a small telescope, it appears as a bright golden yellow star next to a dimmer indigo blue star, which is separated by approximately 10 arcseconds. The brighter member, Gamma 1 Andromedae, is the primary of the system and the component technically known as Almach. The official proper name is used as the traditional name of the naked eye star, but not the system as a whole. The fainter secondary, Gamma 2 Andromedae, or Gamma Andromedae b, is a hot blue main sequence star that was later discovered to itself be also a triple star system. What appears as a single star to the naked eye is thus actually quite a very complex quadruple star system. Reborn as Almach in July 2016, the star is now included in the list of IAU-approved star names. Almach is a traditional name in Arabic, Al-Anak, meaning the desert lynx. The 72nd brightest star in the night sky, the star has an apparent visual magnitude of 2.26. So you might ask, why have I decided to focus a video on this interesting, but so far not particularly outstanding star? Well, the thing about Almach is that it has an estimated 24 times the mass of the Sun, with an age of 6.5 million years. And this incredibly makes it actually the most massive star in our local 1000 light-year area, according to my research. Which certainly does add an interesting conundrum to consider, doesn't it? We're talking about a star that is heavier than Rigil, Betelgeuse, Antares, or even the mighty Deneb. Why then is it so comparatively dim, given its relative close distance compared to those stars of just 350 light-years? Well, although Almach is actually a massive star, not all massive stars have the same intrinsic brightness. The luminosity of a star depends not only on its mass, but also on its temperature composition and volume. The effective temperature and spectral type of Almach determine its luminosity, and it's classified as a K2 2b star, which means it is an orange, relatively cool star, yet bright giant. The B means that the star exhibits some spectral peculiarities. Not only this, but the presence of interstellar dust between a star and an observer can absorb and scatter starlight, making the star appear dimmer than it might otherwise be. In a recent video regarding Zeta Ophiuchi, we even discovered that even Wolf-Rayet and O-type stars can also be significantly dimmed by such dust, and indeed this effect may vary from one line of sight to another, and it may be more pronounced for some stars, which is likely in the case of Almach. It can also be affected by the particular side of the star that faces us. This K-type giant has a warmer, more reddish appearance, which also might contribute to perception of dimness compared to stars with a blue-white hue. Almach and Gamma Andromedae 2 have an orbital period of about 5,000 years. As we see in this picture, the primary pair exhibit a striking colour contrast between the yellow-orange giant and the blue companion. While Almach and the Triangulum Galaxy are not physically related or gravitationally bound, they appear in the same general region of the night sky. The constellation Andromeda, where Almach is located, is adjacent to the constellation Triangulum, where the Triangulum Galaxy is found. Triangulum, unlike Andromeda, is quite dim. An apparent magnitude of 5.72 means it's barely visible to the naked eye, and certainly not inside cities or other areas of light pollution. Andromeda, for reference, shines at plus 3.44 apparent magnitude. Triangulum Galaxy is a spiral galaxy, and the third largest of the local group of galaxies, which includes the Milky Way and Andromeda. A close neighbour, relatively speaking, Triangulum is a member of the local group and is approximately 2.7 million light-years from the Milky Way. As the third largest in this local group, it follows the Milky Way and Andromeda galaxy and has a diameter of about 61,000 light-years, and this can be compared to the Milky Way's 105,000 light-years or Andromeda's 152,000 light-years. While smaller than obviously both those galaxies, Triangulum does remain a relatively large galaxy universally speaking. Indeed, it has a galactocentric velocity of -44 km a second, which means the entity is slowly moving towards our own galaxy. and it's thought that after an initial collision of Andromeda and Milky Way, Triangulum will also combine with us at some point in the future. How then the Milk-Dromeda galaxy by then will be renamed is anybody's guess. I think I'm going to go with Milk-Dromulum, but concede there are probably better names to be found. Let me know in the comments if you can think of a better one. The age of Triangulum is estimated to be around 10 to 12 billion years, but we also must keep in mind that the age estimation for galaxies involves some uncertainty, and different regions within the galaxy may have slightly different ages. In our own Milky Way, for example, some globular clusters may have been swallowed whole by the larger structure, but remain more or less intact within the galaxy itself. The Triangulum constellation itself is a pretty unremarkable sight, and is a small constellation in the northern sky. Unsurprisingly, it depicts a triangle, and its brightest star in the constellation, Beta Trianguli, is actually a binary system itself located 127 light-years from Earth. It's only a third magnitude star. In today's graphic, we continue our focus on that part of the sky, and we see a much brighter Triangulum Galaxy than is actually the case for effect. Above, we see Almach just northwards of the constellation, and we begin to imagine what the star would appear like if it were to approximate our solar system. Currently 350 light-years away, if we were to pretend it was actually 100 times closer, at 3.5 light-years, the star would increase in brightness to eventually reach a magnificent -8.36 apparent magnitudes, which for reference is some 40 times brighter than the planet Venus at its very brightest by my calculations. As we approach Christmas in the year 2023, what a sight that would make if it were to come true, and it would almost be bright enough to read books by. Almach, or Gamma Andromedae, is the heaviest, most massive star in our local 1000 light-year area. It's found in the same area of the sky as the wonderful Triangulum Galaxy, the third largest in our local cluster after Milky Way and Andromeda. The luminosity of the star depends not only on its mass, but also temperature composition and volume, and Almach is a cool giant star that fails to outshine other stars less massive than it, like Rigel, Deneb or Sirius. Triangulum Galaxy for its part is approaching our solar system, but it also remains relatively faint to see with the naked eye. If the star of Almach were to approximate our solar system to just 3.5 light-years distance, it would outshine the planet Venus by over 40 times. This mysterious orange giant star is approximating our solar system, as is the Triangulum Galaxy. The galaxy, however, will take longer to reach the closest approach, and by then, the star of Almach will long since have passed back into the void. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so, and if you have any videos or subjects you'd like to see brought to life, let me know in the comments below. It could be your idea next week that shows up. Take really good care of yourselves, look after your friends and your family well, and I'll see you on the next one.